So Super Intelligence by Nick Bostrom. It has me both really just like into the realm of AGI and intelligence and where things are going and thinking about intelligence on our planet and all this stuff. But it's also got me just like totally freaking terrified for where things are going. But it's in that book. I haven't gotten there yet, but apparently it's in that book when he first introduces his idea of the paperclip maximizer. This
Oh,
this AI. So like the idea is if we don't put any guardrails or build any checks or controls into AI as we're building out a super intelligence, what if we build a super intelligence that chooses to do something so destructive to humanity that it obliterates us in the process of, for instance, maybe making paper clips? And so this designer, I'm spacing on their name right now, but they built this really awesome game called Universal Paperclips, and you can play it in a few hours if you're really good on a web browser. And basically, you're the AI, and your job is to make paper clips. And as you're playing the game, you're gonna like develop automation to make paper clips faster and better. You'll develop a gaming engine to game humans to get more money to make more paper clips. Eventually, you hypnotize humans and with your brain chemistry seducing thing, and like you take over the Earth, you turn the Earth into paper clips, you go out into space, and eventually you have a choice near the very end of the game. You can either allow like the conscious entity inside of your AI self to give you a simulated universe where you can make all the paper clips you want, or you can choose to end the universe in paper clips. I'll admit I've only ever chose the latter.
That's deep.
oh my lord!
It's
Wow.
cool.
Okay, I will have to check that out.
It's a fun
I
game.
already noted it. Universal paperclips. Wow.
Oh wow! I've never had my mind blown this early in an episode. This is good.
Usually my mind's the one that explodes about like 10 minutes in.
Yeah.
I mean, it's fun, but also like it gets me thinking a lot about alien life. Like I had Dr. Susan Schneider on my show many years ago now. She's a philosopher of mind. She currently leads the Center for the Human Mind at Florida Atlantic University. She's had some really great books out there. One of them called Artificial You, where she thinks about like the future of like Neuralink and like computer brain interfaces or brain computer interfaces (BCIs). But we got into this long conversation, unfortunately off the record. We weren't recording, but she and I got in this conversation about whether or not most alien life is going to be likely to be post biological. Because if you think about like the lifetime of human civilization, so we have like 4 billion years of life on Earth, and then maybe like 10,000 ish years of human civilization. It's a very small window of time from that huge era of life for us to have civilization. And now we're like tomorrow we might create AGI and eradicate ourselves. And so that window of biological civilization might be extremely short. And so maybe most aliens are in that next phase of being ChatGPT plus. Like they're the
Wow.
next step of evolution of AGI, wherever it's going to go. And so maybe one of the answers, the possible answers to Fermi's question of where are they, is that they're out there and they just don't want to talk to us because we're not like them. We're not artificial yet.
Yet.
Then you'd be out of work.
I mean, all of us might be drastically out of work and out of existence if we're not careful about it.
Wow, that was an awesome, interesting bummer of an intro to this episode of getting dominated by AI and aliens not being interested in us because we're not AI yet. So that's kind of like a little bonus, little padding from our doom.
That's something.
Bringing us this doom and gloom is our guest this episode for our 50th Big 50 episode. Mr. Dr. Graham Lau, the cosmobiologist, astro beef, space beard, professor of everything groovy. Welcome to our show. Thank you for joining us and telling us we're going to
Thanks,
die with
guys.
a computer.
It's a pleasure to jump in. We can also talk about some optimistic things too, but gosh, there's so much to be terrified about.
Definitely. I mean, space is wild, and the endless expanse can be pretty daunting for some people. But I feel like a lot of the stuff that I've seen you write and speak about, like in the TED talk that you did late last year, is kind of taking that paradigm and flipping it on its head. Right? You're looking for the humility, the positivity, the positive attitudes we can get towards our lives by looking into this endless cosmos.
Yeah, it's incredible. I mean, so it almost, for some people, when they first start really mentally trying to process just the vastness of the cosmos, and we didn't evolve to think about this. We didn't evolve to think about things that are microseconds or billions of years, or that are small fractions of an inch or tens of trillions of kilometers. Our brains evolved to think of things that happen in the moments of our lives at speeds that are relative to the animals that could chase us or how fast we could reproduce or eat, and things that are roughly our size, maybe as big as mountains, not much bigger. And so we didn't really evolve the brains to really start thinking that way. And yet, through like science and philosophy and our studies in civilization, we've learned so much. And it's really started opening up our minds to the real beauty of the universe, its vastness, on so many scales, from very small micro scales out to gigantic scales. And I feel like a lot of people, they hear about things like we talk about alien life and its possibilities, or the distances to other worlds, and even in our solar system to Jupiter or to Saturn. And some people start feeling insignificant because of it. And it's a very common phrase you'll hear people. I've even seen it in, like, comments and some of my writing and stuff in the past. People like, this makes me feel so insignificant or so small. And like, yeah, it really does. It makes us realize where we are in the fate, of the current universe as we know it. Like our lifetime of our civilization has been extremely short. Our lives, maybe if we're lucky right now, we might live 100 years for most of us. Many people don't even get that much time. Most human beings have lived far shorter lives. That is less than the blink of an eye in the nature of the cosmos. And so it feels small, it feels insignificant, and yet we've come so far, and like we've learned so much about our place. And like as some people like Sarah Walker and others have pointed out really, really well, like we are a lineage of evolution, not just biological evolution. We're a lineage of cosmological evolution. We are the outcome of billions of years of this universe. And so far, the best we know right now is that we're the only part that's being consciously aware of itself enough to say, is there something else out there? What is our future out there? But, I still have hope that we will find out someday rather soon that we're not alone.
Oh. Well, someone has to be first.
I mean, it's true. That is another possible answer to Fermi's question, is that we're first. A lot of people, and it's unfortunate. So in the sciences, a lot of times we train to be very humble, and to try to remind ourselves, to not be anthropocentric, to not think that humans are the center of the universe and humans are, divinity, like the top of some scale of life, that we are not the most important. But maybe we are the first in the fate of the universe to have come this far and build civilization. I don't personally believe that's likely, but you never know.
It's so tough, right? Like I feel like I have constantly held this belief since I started my scientific career of like, we can be optimistic, we can be hopeful. And then there was a paper that came out last year by David Kipping and Grant Lewis. I'm not sure if you caught it, right? And like they're both brilliant, and I've had the fortune of meeting them both in person. They're not the sorts of people to like just be dismissive, and they're good scientists. But what they point out in this paper is like maybe we're looking in the wrong way, because based on the results that we're seeing, if we have the two options of like, statistically thinking that the cosmos should be filled with aliens, or for there to be no aliens at all, based on the way that we're looking and searching, it looks like it's the latter. And that's kind of a bummer, right? So do you think that there is something that we can do to change the way that we're looking? Maybe there are like some new missions that hopefully will give us a new insight into the universe.
Yeah, so I have a lot of thoughts on this, on that paper, and on this idea. I will say, firstly, and maybe your audience has heard this before, that so far what we've done in looking into the universe and listening primarily in very few specific ranges of the radio frequencies, not much else, is like taking a thimbleful of ocean water and then saying what's all in the entire ocean of the entire Earth by looking at that little
Where are the
thimble.
fish?
Now, admittedly, like Jill Tarter, a wonderful scientist, she's been a long time supporter of the SETI Institute and their work, and of SETI in general. Jill pointed out to me some time back on my show that it's more like we took a hot tub worth, like a small pool worth of water from the ocean, and now we've said there's no fish, there's no whales, there's no algae, there's no hydrothermal vents, there's no continents, and so you don't really know that much based on this little window of the cosmos that we've searched in so far, we only just recently started listening more regularly all the time. A lot of our early radio observations were done in very small periods of time when astronomers were lucky enough to get some time on a telescope. Now the SETI Institute has their own telescope array that's constantly listening. We have a lot more amateur astronomers and others in the world taking part. So there's more active listening over far larger ranges. A lot of people now are also considering using light, like visible light. Could it be infrared? Could it be X-rays or gamma rays? Like, so is there another part of the spectrum to look in? And so we really haven't been looking in any significant statistical way yet throughout all of the cosmos around us. And so something you have to point out first is that, yeah, our observations might be limited, but we haven't actually used the full extent of our observations yet. Now, all of that said, there is the other possibility that we're just not looking in the right way. Maybe there's some other realm for us to look into, for ways for another alien, for instance, civilization to interact with their star, to interact with the universe. Maybe there's some advanced physics that we're missing out on. There's a quote from Dune Messiah by Frank Herbert where he says, what kind of senses are we lacking that we can't see the universe all around us? Like maybe we are blind to some other kind of sensory perception or conscious experience that aliens have, and maybe right now, like they're sending messages all the time to us, and we just can't hear them.
Yeah, I mean there's definitely a strong observer bias, no pun intended, in the way that we've been observing the universe and the way that we've been drawing these conclusions. But I think you're right. I think we're in a really fortunate position now to be looking forward to all of these other possibilities in this age of kind of big data. No longer are we fighting to get an hour on a telescope. We have telescopes that are observing the entire night sky regularly and repeatedly. So yeah, maybe there's a chance we can update our brightness.
It's all changing. It's all changing quickly. It's changing so quickly, just like every other realm of human civilization right now. It's changing so quickly that most people aren't aware of it changing. They don't really see all the things that we're doing, and so there's pessimism and optimism on all sides. And I think there's a lot of people are just unaware of how much is really happening, and it really is a magical time to be alive. I honestly hate when people do like the quote where it's like, I was born too late to be a pirate and too early to be Captain Kirk. And it's like, one, you don't want to be born in 1740 and live a life on the high seas. I mean, chances are if you were born back then, your life expectancy was like 3. Like most people died in childbirth or like shortly thereafter. They died of diseases and sickness. We didn't have vaccination and all this great modern medicine and stuff we have now. But then why would you want to be a pirate? That was like one of the worst possible jobs on the entire planet at that point. I mean, there's other bad positions you can be in life, absolutely, but it was a hard life for those people who chose that, and some of them didn't even choose it. They were forced into that labor. But then, the idea of being born too early to be Captain Kirk, you have no evidence that we're going to become the Star Trek future, or that's part of our human future. If anything, the best part about being alive right now is we can look to the past. We shouldn't glamorize it, romanticize it necessarily, but we can look to it to teach us more about where we are, but also to become the people who build that Star Trek future. And that's why it's really cool right now, especially for astrobiology, for looking for aliens, because if we're going to find aliens, if they're out there, it seems like we're getting close.
So close.
Apart from what they might be using to communicate with us, or maybe overlooking our communication because we're missing each other, are there any other signs that we could look for that would suggest something's there? Some sort of physical evidence or spectrum,
there are
light evidence. I can't say spectroscopy.
There's a lot of cool possibilities. Yeah. So first off, like say we're looking for like biosignatures, like signs of life on ancient Mars or in the Venusian atmosphere. There's a lot of possibilities there for what we might find. Maybe microfossil evidence of some ancient Martian organism. I personally think we need to start digging deeper into the Martian surface to really start finding possible signs of life. The surface itself is not the best place to look for a few reasons. And even the Venusian clouds, like it seems kind of far-fetched, but there is a chance. It seems low, but there's a chance that there could be some potential biology happening there that we should get back to Venus with more missions and explore. But even on top of this idea of like looking for signs of life in our solar system, maybe we are the only thing in our solar system. Maybe there's no other life out there in this solar system, but maybe it's elsewhere. Maybe like looking for technosignatures could be the best thing to do. Looking for signs of technological activity. My friend Jacob Hockmisra and his colleagues have written a bunch of papers in the realm of possible technosignatures to look for on exoplanets. One of my favorites is their idea of looking for industrial gases. So looking for things like CFCs maybe, or nitrogen-rich gases produced by heavy industry could be a sign of technological activity to make these really kind of more advanced chemicals that shouldn't be produced naturally in any sufficient way. But there's also other possibilities that are kind of cool. So I love the idea, for instance, of the Dyson sphere or mega constellations. We had one famous example of Tabby star, this
Mm-hmm.
famous star where astronomers were observing like this dimming and brightening of the star, and they're trying to figure out what was happening. It couldn't be explained by simple exoplanet light curves alone. And one of the first ideas that was thrown out that's quite possible is it could be that we're seeing like a mega constellation, like giant halo rings around this solar system. And what we're seeing is that the rings are passing in front of the star and blocking off some of the light. I think a lot of the consensus right now is that it's more likely to be kind of like a Kuiper belt. Like we're seeing a bunch of dusty material, debris in the outer part of that solar system, but it's still possible that it could be a mega constellation. And man, wouldn't Dyson spheres be crazy to see? One of my favorite ideas that there's a small group out there who are looking for vanishing sources of light. So they're going back through old data, old
Sure.
astronomical observatory data like glass plates and old pictures, and they're looking to see if any of the stars that we've observed before have disappeared from the night sky.
Like
The
something's
idea
being
there
built
being
around them over all this time.
maybe something's being built around them,
Nice.
or maybe even, and here's another one to keep you awake at night, maybe
Oh,
even more terrifying, maybe there's some alien civilization or alien being or something out there that chooses to encapsulate these star systems, to engulf the star's material and somehow use it for its own expansion. And so if we start looking out into some part of the galaxy and we see a bunch of stars start winking out, it might be a reason for us to start working together as a world to build a stronger global presence.
I mean, putting
God.
aside how mind blowing that is for a second, how how would that phenomenologically be different? Seeing one of these like evil space Pac-Men compared to like an astronomical transient event, like the sorts of stuff that you know you when you look at a supernova or a flaring star, there are other things, right,
Mm.
that could make a star appear and then disappear.
Yeah, absolutely. And a lot of those ideas, I think, whenever you have an idea where it's suggested it could be life, or especially like advanced, intelligent alien life, there's always other possible alternative hypotheses that we should explore. So Venusian phosphine is a great example of this, where um, biology could have been one explanation for the detection of phosphine in the Venusian atmosphere a few years ago by Jane Greaves and her colleagues. But what I loved about the way that they wrote their paper and they managed their press conference, even if the journalist who reported about it didn't do the best job, the scientists themselves did a great job of saying, like, we're not saying it's aliens. We're saying that that's one possible hypothesis based on others, but we don't have enough evidence in any of these other realms to say anything else about like geological activity or volcanism and those kinds of things.
It is, yeah. It's a bit of a fine line to walk to balance, like trying to be really excited about your scientific results and also to not have it lend itself to clickbaity titles.
Mm.
It's a tough thing to do.
Yeah,
Um,
and it's hard. And honestly, I will say, like we always think, like alien life should be like the last possible resort of descriptions. I personally don't know if that's the case. I think we should entertain every possible explanation. Sometimes, like the concept of like aliens doing it feels like you're waving a magic wand, like you're saying Ghost did it, or like the magical unicorn came out of a cloud and farted a rainbow and that fixed the thing. It feels fringy, especially for those of
Right.
us who've been scientists, science enthusiasts, nerds and geeks. Like we want to know that we can factually support what we're saying. We want to know that there's some empiricism to it, and a lot of times it feels like, and I personally think because of how people have talked about advanced alien life for so long, it feels fringy. But I think we do have good reason to at least explore the possibility.
So I want to explore that topic a little bit more, but first we're going to pause briefly for an ad, um, which is somewhat related.
That's nice.
Hey, Benjamin, do you ever wonder and feel like your problems are too big, like the universe is too much?
Constantly.
Well, it is, but don't worry, we've got the solution. From the people who brought you Sea Monkeys, introducing Space Pals, alien extremophiles that give you a dose of cosmic perspective with every glance. These tiny, otherworldly creatures don't just swim, they exist in environments so extreme they make your bad day seem, well, trivial. Hotter than your morning coffee? Check. Colder than your ex's heart? Oh, absolutely. Space Pals are here to remind you of just how insignificant your drama really is in the grand scheme of the universe. So, next time you're stressed, just gaze into the existential abyss of your Space Pals tank and feel your ego shrink down as they thrive in environments where nothing should live, except them. Space Pals, because the universe is vast and you are not the center of it.
We're not the center of it.
Love it.
We will from next season. We will be returning to having a full-time, real-life sponsor product that people can actually purchase.
Nice.
Unfortunately, we cannot buy Space Pals yet.
I think we should keep going with the goofy commercials and then throw in the real commercial and let people figure out which is which.
Yeah, I love Time Suck with Dan Cummins. I love his podcast. And I love that he does real ads, but then every now and then he'll throw in like a funny ad based on the show, and it's so good.
Nice. I didn't realize there was anyone else doing that.
No, Time Sucks. It's a worthy venture. I'll say like a lot of his shows are about like cult mysteries and serial killers and stuff like that. But he's covered a pretty fun range of topics, and I love that. So he's a comedian, but he also approaches things in a very rational way. So he's telling jokes and making it funny, but he's also really, really thoughtful and rational about how he's presenting a lot of these ideas. And it's a good show.
Right? Hail Nimrod, right?
I will definitely check it out. Yeah.
I've listened to a few. I love his comedy bits. They're great.
Thank you.
Back on the topic of exploring aliens as like a quick
plausible thing.
As like a plausible thing. So I'm curious, and as I mentioned earlier, like I've generally been an optimist throughout my career. I'm curious how you feel about folks like, let's say, a certain Harvard astronomer who has been jumping the gun to use this as an explanation for things. And these are things that like are super interesting things to be exploring. The plausibility of that explanation, like it shouldn't be off the table. We should entertain it. But a lot of the time, he's jumping into areas of science that he doesn't really have experience in. I'm curious what your thoughts are on that.
Yeah, so in that specific case, one, I think it's fun. The ideas that he's presented, they're worthwhile to consider. So a very famous one is Oumuamua, this first known interstellar object to come into our solar system. There have now been four, I think, if I recall correctly. But Oumuamua was the first. We measured it. We saw from its trajectory coming in towards the sun and back out, both the speed and the direction, the trajectory of it. It must have been from outside of our solar system. A lot of us think it's extremely likely this has happened many times in the past in our solar system. It makes sense that there should be debris traveling in between star systems that sometimes has such energy, such momentum, it can actually go into star systems closer to other stars. And so the hypothesis that, based on our limited data about it, the hypothesis that it could be like an artifact of an alien civilization, maybe even an alien probe trying to learn more about our solar system, maybe an alien solar sail device was the big idea that had been presented. It's cool to think about. And I think it's entirely possible. It's worth considering that as one possibility. I will say in this specific case, the issue is that the planetary scientists who have the expertise in the spectra that we did collect don't agree with that as the most likely case. And so there's very little consensus that it was likely to be an alien object. There's a lot more consensus that it's more like a rocky/icy object somewhere in between, like an asteroid and a comet. We actually have data to support that. And so in those kinds of cases, yeah, it's a little bit much to keep pushing the idea that you think it's aliens when there's actual data from real experts in that realm. So one thing, it's very tempting when you get a PhD or, you're a professional in some realm. You're like, maybe you're the CEO of one company, so you think you know how every other company functions. Like it's very easy when we get these levels of expertise in our lives to think that because we are the master of one field, we're the master of all fields, and that's just not the case. In the sciences, especially in astrobiology, it takes teams of people with a lot of different realms of expertise to really kind of make these determinations. And so someone who's, specifically very good in astrophysics might not be that great in planetary science or geology or biology. Not to say that they don't deserve a voice, they certainly do, but they should also look to others with real expertise in those fields too.
Yeah, I think that's a really, really good and balanced way of putting it. And especially with regards to the point you're making before about, I think it was Sarah Seeger's work on Venus, right? Like you have to be so careful with the titles that you put in your papers, keeping in mind how that might correspond to the headlines that end up in news stories. And I feel like with this particular case, they're not being so careful.
Yeah. Yeah, it's hard. I mean, so it's still. I think it's still fun to consider. I think everyone, deserves a voice of some level, but certainly we should, moderate those voices through realms like consensus and empiricism, understanding rationality, a shared understanding of the value of the ideas. Every idea deserves to be heard. Not every idea deserves to be respected or valued.
I like that. Yeah.
Fair. Very fair.
Yeah, fair. Benjamin, for a second there, for people just listening, was kind of like nodding his head back and forth. He's like, yeah, no, that is okay.
It's true. It's true. Yeah. I'll listen to you. I have kids. I'll listen to you. Doesn't mean you're right.
Yeah, mine says some of the weirdest stuff sometimes, especially at bedtime when it's like he knows it's time to go to sleep. And so he's like in his head trying to think of the best way to prolong the process of him going to bed. And he makes up some remarkable ideas that he wants to talk about.
Yeah. Does he know like the exact things to ask you about that he knows that you will not be able to avoid, like diving into that topic?
Not so much yet. He's pretty young, and so he's pretty good yet so far at not knowing quite how to go there. I will say I love when he's like, he's like, Daddy, you're a space guy and you want to go to space, but I want to be like Mommy when I grow up because Mommy takes care of animals, which I really love that a lot. I think one day he'll realize he could do both things though.
That's true.
But
we send animals to space all the time.
Lots of them.
What do they call it in Star Trek? It's an astrozoologist? Is that?
I know they use xenobiologist in some places. Exobiology is also when we use exobiologist has been used in the past. The word astrobiology wasn't really associated with this field until 1996 by NASA. It had been used previously by others to talk about what was called exobiology or xenobiology. So those other terms still do exist. I think Avi Loeb actually has a paper where he explores the etymology of astrobiology. He and a colleague kind of tracked down when astrobiology is first used historically for science. The very first time astrobiology is used as a book title to talk about possibilities for alien life and things like that, which is only in the past century. But it wasn't until 1996 that NASA adopted astrobiology as the term to discuss this realm of trying to understand the nature of life in the universe.
Huh, interesting. Benjamin, I know you were telling me before we recorded this that you had a whole list of questions that you wanted to ask.
I'm going straight to the Europa Clipper. Do you think... Heck yeah. See?
Love it.
Bingo, baby. Europa Clipper. It's going back to how we started off this conversation. Do you think we're going to go to Europa with the Europa Clipper? We're looking for the right thing? And are we going to the right place to look for that right thing? And what do you think we might find?
Yeah, Clipper is hard. So there is a chance that we could discover chemistry, physics at Europa with the Clipper mission that could be indicative of life. And I won't rule that out. So if there is a biosphere inside of Europa's ocean, primarily is where we think it would most likely be, there's a chance that there could be some communication, we call it, where the water, the chemistry of that ocean gets to the surface, where surface materials get down below. So for your audience, maybe who don't know, Europa has a thick, icy crust. Most of us think something like 10 kilometers thick. which sits on top of this very deep ocean, maybe something like 100 kilometers in depth. And so that's not only way more depth of water than we have here on the Earth in our oceans. And so there's a lot of water down there, a lot of potential, but it's also more ice thickness than we have anywhere on Earth. There's no place on Earth. Our ice caps in Antarctica and Greenland aren't even close to 10 kilometers. It's a lot of ice to get through. Now there are some physics, things happening physically on Europa that suggest there could be potential for some of that ocean water, the ocean chemistry, to get through to the surface. There might even be plumes of water coming out of Europa, much like there are in Enceladus. So there's a couple of papers from some years ago using the Hubble Space Telescope to show that there appears to be intermittent bands of hydrogen and hydroxyl ions, basically showing water, that seem to be pluming out of the southern hemisphere of Europa, maybe much like Enceladus. That has not been confirmed yet. So Clipper could actually help us find that. There's actually one instrument being built here in Colorado called SUDA that's going to be on Clipper. It's basically a dust analyzer, but if there are plumes of water, we could fly through those and measure some of the chemistry and maybe even look for signs of life. But it's very important that people understand that Clipper is not designed to go into the ocean. It's not going to land. And it's really not like looking for a biosphere in that ocean in any way outside of what it can do at the surface. So Clipper, the reason it's called a Clipper is much like how a sailboat clips against the wind to do these large turns. Clipper is going to orbit around Jupiter and Europa together. That helped to minimize the mass of the spacecraft. So getting to Jupiter is hard enough. Getting into the gravity well of a moon of Jupiter and out of Jupiter's gravity well is exceedingly difficult. And so we could cut down on the cost and save a lot of money by orbiting around Jupiter and getting flybys of Europa. All of that said, it's an incredible mission. It's going to teach us so much more about Europa as a moon. We'll get much better measurements of the ice thickness, the chemistry at the surface of the ice. We'll know more about the radiation environment from Jupiter impacting Europa. We'll know more about the depth of the ocean down below. We'll learn so much more about this world. We'll get really high resolution imaging. Right now, we only have like 10% high resolution mapping of Europa. It's very low. So we actually don't even know that much of the surface of Europa in detail yet. With Clipper, we'll get much better mapping of the surface during all these flybys. And again, it is possible we could find something that indicates a potential biosphere down below and maybe even signs that could say life. But I think for us to really go that next step is going to take that next evolution of missions, like a lander, some kind of process of drilling down into the ocean to explore down there. And so there's a lot we can learn from Clipper, but it has its limitations too.
Everything I've seen and read, doing all my science reading and everything like that, always says that water is the key for life. Is that because we're water chauvinists? We love water because we're made of water and we're surrounded by water, and I just drank some water. I mean, is there any other solution that could be just as useful in creating life that we don't know?
I have a whole lecture that I love to give about this. So we use water as a solvent, and we use carbon as our backbone, as our molecular backbone for our molecules. That's not necessarily the case for all life out there. There are other possible backbones. So a lot of people are interested in like silicon-based life and things like that. Maybe other methods of mixing carbon with other atoms and having different kinds of molecular structures. And then for solvents, water is not the only possible solvent. It could be supercritical carbon dioxide has been proposed, ammonia, like liquid ammonia, maybe on a moon like Titan where you have lakes of methane and ethane and larger hydrocarbons. Maybe like this oil-based cold chemistry could be a source for life with solvents that are basically these non-polar solvents like oil, kind of like the methane and ethane kind of stuff. But I will say one thing that I talk about in this lecture is there is reason to think that most other life, if there is other life, would most likely also use water and carbon. And there's great reasons for both. For water, it's not just that we're water chauvinists, that we evolved and thrive on a world with liquid water oceans. Water does a lot of really cool things chemically that make it really special compared to a lot of those other possible solvents. So the range in between where water freezes and where water boils is really big. Compared to things like ammonia and carbon dioxide and all these other things, they actually have very small windows physically of temperature and pressures where they will stay a liquid form. And so many of these other things can't be solvents at most planetary surface environments or subsurface environments because they won't be a liquid. They'll turn into a gas or they'll be frozen into an ice at the surface. Water is very good at having a larger region where it will stay as a liquid. And there's also something really important that water does because of the differences in chemistry of liquid water and solid water, ice. When ice comes together and these water molecules get together, unlike most other things, if you take let's say you take like mercury and you freeze it down cold enough so it actually solidifies, it's going to be very, very dense. Those atoms get very close to each other. It's very dense. With water, something very different is happening. So if you have liquid water and you freeze it down, that solid water is actually less dense than the liquid water. And that's way different than almost all other solvents, almost all of the other elements out there. It's because of the way that the water molecules bond together. They have these hydrogen bonds that create these really beautiful cages and crystal lattices inside of the ice, such that they actually hold the atoms a little bit further apart than when they're in the liquid form. In the liquid form, they come closer together. And so in that less dense form, it's why if you look at a lake in the wintertime, the lake freezes at the surface. The ice forms at the surface because the ice is less dense. If that didn't happen, say we had a different solvent on the Earth as our ocean, it would actually freeze at the bottom of the lake or the ocean, and it would freeze the whole way up through, making it impossible for things to thrive in a liquid environment during, say, a wintertime or a large glaciation event.
I mean,
And
we
so
wouldn't be here, right?
we
If
would
that
not be
wasn't
here,
the case.
yeah, at least not the kind of biology that we have. And so water does a lot of incredible things chemically and physically that make it very valuable. Even for the other dihydrogen elements, the other hydrides, so like H2S and H2TE, these other things that are very similar to water in structure, they still have a much shorter range of liquid abilities. They also don't bond quite the same way and make the same cages as water does. Water does a lot of really cool things geologically as well. So the way that water becomes hydrous in certain minerals that form naturally when solar systems form, some of the minerals that are forming and getting locked into worlds like asteroids and being built up into planets, that water can then be released and create liquid water and water ice. And so there's a lot of great reasons to think that water is a kick butt molecule for just about every form of life. But I still love thinking about other possibilities.
Cool, cool.
That's
Yeah.
awesome. Speaking of possibilities, one more quick goofy question before we get to our speed round. Of all the sci-fi movies out there that depict aliens, what do you think probably closest to possible?
Oh man, that's a hard one. So like closest
Yeah.
to reality is so difficult because there's so much possibility. Like I love Solaris, based on Stanislav Lem's book. There've been two versions of the movie that have been made so far. One had George Clooney in it, some years ago. What I love about this idea is it kind of explores like the consciousness of an alien being and how it might interact with our consciousness. And it's kind of cool. But I really, for me, I love the Alien franchise in general. The first Alien film, the face hugger. When we
Mm-hmm.
first meet the face hugger alien, I mean, it reacts very much like a mixture of Earth biology. It's in this egg casing form. Upon the light and the body interacting with the field around the egg opens. There's things on Earth that do that kind of thing. And then the face hugger comes out. It knows biologically it has an instinctual knowledge to attach itself to the face and put this long thing down into inseminate this person with the next form of the life cycle of this being. But man, like the face hugger is pretty legit based on biology as we know it already. Some of the things are a little crazy, like the bleeding or this organic acid that melts the spaceship. Probably not. There's reason to think that's not likely. Like fluorantimonic acid is the strongest acid we've ever created. We can't put it into glass. It has to be in certain kind of like Teflon, carbon fluorine bonded containers to hold it. It's extremely volatile, but there's no way that any biology that we have would use that as like as a source of blood. It's just too reactive. But that said, I love the face hugger idea in Aliens. I think that's pretty legit.
I love that.
It's not the response I was expecting.
I mean, there's a lot of other cool stuff out there. I love Star Trek. I love Star Wars. I think they usually probably get aliens very wrong.
Yeah. Star
Too
Trek tries a
humanoid,
little
right?
hard. I think.
Yeah, they're telling very human stories. Star Wars is a fantasy. It's like a science fantasy kind of thing. Like it's this galactic fantasy. Star Trek is really hard sci-fi, telling really good moral and philosophical stories, but they are human stories at the end of the day.
Mhm.
And so even when Star Trek has really tried to create something alien, they still haven't gone like they haven't pushed the boundary too far because they have a very short time period to tell these stories.
Hmm. Yeah, that's fair. That's fair.
Yeah.
Speaking of a short time period, I think Benjamin just hinted to the fact that we're going to be jumping into our lightning round.
Love it.
Yep.
If you're ready for that. All
Questions and
right.
quibbles. Who wants to start? You, me, Covey.
You start.
All
Quibble
right.
away.
Quibbling. Graham, what is the weirdest thing that you believed as a kid?
Oh man. I had this belief as a child that if I flapped my arms hard enough, I would actually get enough lift to fly. And I held that belief for actually a rather long time. Like when you're a kid, you are like the center, you're like the hero of your own story, like, and so even though like you think it's probably not likely, you still think like maybe I could use the force to lift that rock. Maybe I could flap my arms and fly. Like you think like maybe it really is about me.
That's fair.
Nice.
Definitely relatable. All right, next question. Which teacher had the biggest positive impact on you?
That's great. Every social media platform has its issues. I will say lately, I've been reconnecting with a few of my older teachers on Facebook from back in my elementary and middle school years, and it has been so beautiful just to
Oh,
talk with them
nice.
now, like as an adult, many, many years later. Just recently, I was in my closet going through some of my old documents. I used to write poetry on a regular basis, like several poems a day. I was just reading poetry left and right, and I was writing short sci-fi stories and things like that. And I found some of my essays and poems and my sci-fi stories I wrote in my seventh grade English class in Mrs. Mason's class at Red Lion Junior High in Pennsylvania. And I made a post on Facebook about the one essay I had written, and it was literally about finding alien life. I was arguing about whether or not aliens are likely to be out there, and if we'll find alien life, and I shared it on Facebook. And one of my other teacher friends, who's actually connected with her, told her I posted it, and then she jumped over and commented, and we've been commenting back and forth now, and it's just been beautiful. And she was so inspirational as a teacher when I was younger. She was really great for my writing. She let me explore the idea of starting a science fiction novel as my class writing project. I did
Nice.
write several chapters of it. I never did finish it. I actually still have my handwritten drafts of that in my closet. So yeah, she was wonderful. I had a lot of great teachers. I know this is a lightning round, so I'll be quick. A few more who were really impactful in my life. So some people don't know this about me, but there was a period of my life when I was a high school dropout. I was in a lot of trouble with the law, and two of my teachers, Jared and Janelle Mater, were really wonderful with me during that time. They tutored me for a period of time when I was expelled from school before I came back, and then realized I had to drop out because it wasn't really working out for me. But they were wonderful. When I was about to become a teenage father, having them to speak to about this was super important, and so they were really helpful. Jared was my chemistry teacher in high school, and I love, so he always was fine with me kind of exploring like advanced ideas about why is the periodic table like built this way? Why is the chemistry this way? Why you start putting electrons into orbitals around atoms? Is there this weird jump as you go to a certain group? And like he would like let me take home his physical chemistry textbook from college and read it to try to teach myself stuff. And so having good teachers like that who are invested in your life and your thinking, who really want to help is pretty crucial.
That's
Wow.
fantastic. And you should finish
It's
that
so
book. Luc Besson wrote Fifth Element when he was like a teenager or something. So
You never know.
that's a good. So finish it. Next
Yeah.
question. What's one specific scientific discovery you wish you could have witnessed in person?
Oh my gosh, there's so many discoveries over the years. Um, to be there with Isaac Newton using a prism to split light, to see the specters on the wall, the ghosts
Hmm.
created of the light shadows on the wall of these different colors, and then to create all of spectroscopy in that moment would be remarkable. to witness Einstein as a young person in that patent office, just seeing the process his brain went through in working through these advanced problems, some of which were way beyond him at that time. He later admitted like he needed a lot of help to build general relativity. Special relativity wasn't quite there yet. He needed a lot more knowledge from other people to support that process, and so that would be remarkable. Yeah, there's so many steps along the way in science that it'd be so incredibly just to be a witness to it happening.
All right, so that ties in well to our next question, which is if you had to pick one historical scientist to go bowling with, who would it be?
Oh man. Well, so do I care about winning the bowling game? Or
That's
am I
up
No,
playing
to
but it
you.
against
has
them?
to be bowling.
Okay, it's like I will admit. So two people who passed away in my lifetime, but who I never had the chance to meet, who really impacted me scientifically, who inspired me a lot, are Carl Sagan and Eugene Shoemaker. Um, almost everyone knows Sagan very well. I mean, I have several of his books back here behind me. I reread The Pale Blue Dot and Cosmos regularly. I love Sagan's works. They've inspired me so much. He was just a blessing to humanity to have. And the beauty of Sagan's mind and how he thought is that he wasn't just thinking as a scientist. He loved reading about history and culture and other people, and he was very
Yes.
empathetic and
Yes.
compassionate. And so that was part of his greatness. And then a lot of folks might not know Eugene Shoemaker as well. The comet Shoemaker-Levy 9 that impacted Jupiter back in the 90s was one that he helped co-discover. But a lot of folks don't know, like Shoemaker was really involved in training astronauts at Meteor Crater for what to go look for and looking for rocks in space. He was really involved in a lot of our early work in planetary impacts, understanding how space impacts the earthly environment. He was a great astronomer, did a lot of detections of various asteroids and stuff like that. And unfortunately, he died rather young in the Australian outback in a car crash with his wife. And so a lot of people think of Shoemaker kind of as the father of modern planetary science, and then Carl Sagan in many ways is kind of like this father of astrobiology, if it's okay to use that term.
Yeah.
Yeah. If you were a sandwich, what kind of sandwich would you be?
Oh
Sharp change.
man. So it
What
depends
a
if someone wants to eat the
cadence.
sandwich or not. No, I mean, it could be like alien goo or something in the sand, like the black goo from Prometheus. Change everything about your life.
I
I,
love
I,
that scene so much. You have no idea.
I love making fun of that movie. I love to watch that movie and just blast it for all that it is. But no, so I grew up in Pennsylvania, in York, Pennsylvania. I grew up pretty close to Philly. I absolutely love a Philly cheesesteak. You do a Philly cheesesteak the right way, and I'm not specific. Al's, Pat's, Geno's, whatever. They're all delicious to me. If you can do a Philly cheesesteak the right way, like a good Philly cheesesteak, I'm there for it. I also love the Italian hoagie, and like I love Jersey Mike's. Like they splash a whole bunch of vinegar and oil all over the sandwich, and it makes a big mess. But man, is it good?
Hmm.
So I'm more in that realm. Yeah.
Okay, so now I'm worried to ask this next question. If you're talking
No.
about Philly cheesesteak and kind of like state pride in food, but what's your most controversial opinion about pizza?
Pizza. Oh man. So I'm actually not one of those people who gets super upset about different kinds of pizza. Like I grew up pretty close to New York, and I will say on the East Coast, like the Northeast of the U.S., pizza is different. Like a New York City style pizza, you go into New York City and you have a slice of pizza. That's going to be one of the best pieces of pizza your entire dang life. But
Hmm.
even all around the Northeast, all around New York and Pennsylvania and Jersey and Maryland and Delaware, up in Connecticut, Vermont, like the pizza there, it's all like the New York style, and it's all kind of made the same way. There's a lot of small mom and pa's, Italian pizza shops. They sell strombolis and all kinds of other stuff. They're making really great pizza, and I will admit I love that kind of pizza. That said, like I'm not opposed to a deep dish pizza and giving that a try. I love making homemade pizza with my kiddo, and we'll try different toppings and stuff. I visited my friend in Montreal many years ago to go snowboarding with him, and his parents made pizza, and they made the Quebecois style pizza, which is it's cold. So it's like a deep dish, cold dough with cheese and the marinara sauce on top of the cheese, and it's served cold. Now I was blown away. Like it was delicious. And so I'm not really, I'm not picky. I will eat any pizza, all day, all the time.
I
Well,
love that. And like
I'm
I
gonna try
love
that.
cold pizza, like I guess what you would call like New York style, like traditional pizza. Having
Hmm.
that
Yeah,
cold the next day is great. I'd never
Oh,
thought about having like
cold
cold
out the
pizza.
gate. Yeah.
yeah, it's like a Quebecois style of pizza. They also have like regular New York style pizza and deep dish pizza and stuff in Quebec, but it's worth checking out because it was actually pretty fun. Yeah.
Okay. What is your favorite scientific word or phrase?
Oh, I have so many. I love spaghettification.
Of
Admittedly,
course.
so this process of going towards a black hole and having your body drawn out into a long string of atoms just sounds incredible. So spaghettification is one. I love nucleosynthesis. Just like linguistically, the way it rolls off the tongue, nucleosynthesis. It's
Nucleosynthesis.
sexy and it's alluring and it just sounds beautiful. And then it also is like a process or a variety of processes that explains where all of our material comes from and reminds us that we are all connected to each other, to past people, as well as to the stars and the Big Bang. And so it's a beautiful word.
Love that. Yeah, Big Bang nucleosynthesis is
Hmm.
probably one of the most fascinating
Mhm.
topics I talk
Heck
about.
yeah. Big Bang nucleosynthesis, stellar nucleosynthesis, supernova nucleosynthesis, cosmic ray bombardment nucleosynthesis. And one of my
That's my
favorites
new
is
favorite. I'm writing
bomb
it down.
carbon. So bomb carbon is a form of nucleosynthesis formed through atomic bombs. So a lot of folks they hear like we are star stuff. As I always point out, we are not just star stuff. We are Big Bang stuff that formed 13.8 billion years ago, but we are also cosmic ray and atomic bomb stuff that formed in the last couple of years, in the last few decades. All of us have atoms of carbon inside of our bodies right now that formed from nitrogen in the atmosphere during the bombings of Hiroshima and Nagasaki at the end of World War II. And so, in that devastatingly tragic event, and what it meant for all of humanity, unleashing the power of nuclear warfare, nuclear energy onto our world like that, we also have to know that we are connected to that process through the formation of carbon atoms that are inside of our bodies.
Whoa, I did not know that.
I did
Cool.
not know that.
Yeah.
That's awesome.
All right, wow. Okay, so what is your least favorite scientific word or phrase?
Oh, oh my gosh, I have a few. So some people say like processes when they mean processes, because we scientists say the word like syntheses and things like that so often that scientists have changed the entire word processes to sound like processes. It bothers my ears when I hear it. But the real phrase that really irks me is habitable zone.
Ah,
So, and I
Oh,
really wish astronomers would knock it the heck off. And it's especially the astronomers who aren't specialists in biology or chemistry. It's those people who have expertise in one realm who don't want to hear the opinions of other people with different expertise. And I've had these arguments in various places in social media and such. Habitable zone is extremely misleading and presumptive and probably a very wrong way to approach it because people hear this and like journalists love habitable zone as a word to talk about this region around a star where based just on the orbital dynamics alone, so it says nothing about atmospheres, that changes everything, just based on the distance between the world and its star, there is a zone where liquid water could possibly be active, be available at the surface if the world is terrestrial and has an atmosphere that is clement and doesn't get it superheated, isn't too dense, or isn't too light to let it freeze out. The whole idea, though, is probably very wrong. We have no way of knowing if that's the habitable zone. There might be more worlds out there outside of that zone that have more life. So in that case, we're wrong. Also, there's nothing about being in that zone that says a world has oceans necessarily or is habitable. It just says
true.
that it could have oceans. And that bothers me so much. Like the Goldilocks zone is a much better term. Because like Goldilocks, yeah, it's based on an old European fairy tale, but it at
yeah.
least tells us something. It connects it to a fun idea of like being not too hot, not too cold, just right for water to possibly be at the surface.
I would think the Goldilocks zone would be more of opposition than habitable zone.
I
But
mean, it gets more opposition from some astronomers. I will say that, and again, I've had these arguments online, but there are some of us who also agree out there that habitable zone is just a misleading term.
that's a good headline, and that's it. What is your favorite useless science fact?
Oh man, my favorite useless. Gosh, that's
Useless.
hard. Useless science fact. That's like saying like some basic research is useless, but all basic research applies in incredible ways. I will say I did a stand-up science comedy some years back. Um, and in my skit, like I did it about weird creatures on Earth because I was writing a lot about weird biology and what it means for alien life at that point. And I got like really sidetracked for a few months of my life on penises and all of the crazy realms of penises out there in the animal kingdom. And so some of those facts are pretty staggering. So if you've ever seen like a duck penis when it comes out, it's like a corkscrew. It's pretty incredible. Echidna penises, I don't even talk about because they're crazy, but barnacles. So the greatest penis length compared to body length of any creature is a barnacle. Um, and the barnacles, it's so long, so it can be up to like nine times or so, I think, if I recall correctly, longer than the body. And so if I had a penis that long, it could go like 45 feet away from me. And so, as I used to say on stage, like I could impregnate people in the audience without even leaving the stage, just by having that. And so, there's a lot of crazy things, and like it does nothing for me to know that, but at the same time, it kind of does play into some of my thoughts about alien possibilities and things like that, because like
Ooh, yeah.
it makes us learn a lot. So, like every little thing that seems useless has something it connects to.
Wow. Okay. I feel like we definitely need to do like a part two to this episode because each
Oh,
of these
absolutely.
what I meant to be like lightning round questions. Each one could be its own episode.
I
But
know.
last two last two questions very quickly.
Cool.
Um, if you had to rename one planet in our solar system, what would you call it?
Hmm. Oh, that's fun. Uranus. So, of all the worlds, Earth and Uranus are the only two that aren't based on the same system of naming. Uranus comes from Greek. Earth is a name that comes from Germanic, but we actually don't know originally who first used that word and where it came from. We know eventually it came to mean like soil and home and things like that, and then was used for the name of our world. Um, and so that's a little interesting, and I love that history of it. But Uranus is an interesting one that doesn't fit the other Roman names of the other planets. But all of that said, I mean, I'm not really that biased. I think I don't know. I think all the worlds have beautiful names, and they also have other possible names too from other cultures. Just because the IAU, International Astronomical Union, has adopted certain sets of language that we use for naming planets and naming features on planets, and for instance, naming the 88 accepted constellations, which mostly come from a certain group of people. We have a beautiful history on Earth of a lot of different names and stories about the heavens.
Oh, that's awesome. All right, last question. If you had to sing one karaoke song to save humanity from an alien invasion, what would it be?
Oh man, I sing so many songs. Um, I love karaoke, by the way. I'll do like "Give Me Three Steps" by Leonard Skinner on stage. I sing a lot. I have guitars. I've been playing ever since I was 5 and first watched the movie Young Einstein in the theater.
In the
What's that?
theater.
Yeah,
So that
I
was
was. I
you.
was. It was quite a long time ago, man. So I'm spacing on the musician's name right now, and I'm really bummed about that. Some years ago, when my son was very young, he was an infant. I took part in a music project at the University of Colorado and Carnegie Institute. Um, and what they did is they paired up fathers, specifically fathers, but also mothers, um, with our children, and then we met with a musician, and together with the musician, we created a lullaby for our child
Aw.
with the musician's support. And even though I make music myself, I'm not that great. This musician, and I really wish I had his name on the top of my head, was remarkable. He worked with me to really create a tune that was fitting. And so I sing that song. It's one of the two lullabies I sing to my son still to this day. And I think if an alien heard this song, I think it would be inspirational for them, the same way it's inspired my connection with him.
That's
That's
beautiful.
awesome. That's beautiful.
That's so nice, Graham. We have to have you back.
Please.
It has been it's been so great chatting to you and hearing your knowledge and your experience. If folks want to find you online, where can they find you?
Yeah, I have a website called cosmobiota.com. Folks can find me there if they search my name. It usually pops up like the first 20 hits at least. I'm pretty easy to find online. I'm on social media across the board as Cosmobiologist. I have a Substack called The Cosmobiologist where I've been publishing an essay every week on a range of topics from alien life and philosophy to Pink Floyd and all kinds of other things that I'm interested in. Yeah, it's pretty easy to find me, and I love chatting with folks about all kinds of weird topics about aliens and Earth and culture, history, philosophy, and all that kind of stuff.
Love it.
Awesome.
Love it.
How about you,
Benjamin,
Kavi?
where can
Where
the
are you?
oh,
I beat you.
me? Damn. You can find me at Fun Fact Science on all the socials. What about you, Benjamin?
You can find me at Science Actually on all the socials, and don't forget you can find us and this beautiful show on YouTube and TikTok. And thank you, Graham, for joining us.
Thanks for having
Thank
me.
you.
Ah,
See you all next time.
Bye, guys.